The particle in figure below has a negative charge. Its velocity vector lies in the xy plane and makes an angle of 75 degrees with the y-axis. If the magnetic field is along the x-axis, x direction, positive x direction, what is the direction of the magnetic force on the particle? So, first of all, in order to find out the direction, we need to use the right hand rule. Which thumb is going toward the velocity vector, four fingers toward B, which is in this direction, and then the palm of your right hand is going to show you the direction of the magnetic force. And since it's a negative charge, as it says here, we need to make it opposite the final answer. Or we need to use the left-hand side. So you use only one of them. So here, when you have thumb toward V and four fingers toward B, and then the force is going to be downward. But since we are dealing with negative charge, we need to make it opposite. So force is going to go toward positive sides of Z-axis. So that's going to be the direction of the magnetic force. Now, second example, a particle of charge negative 7.9 microcoulomb has a speed of 580 meters per second. The particle lies in the xy plane and travels at an angle of 55 degrees with respect to the x-axis. There's a uniform magnetic field of magnitude 1.3 Tesla parallel to the y-axis. What are the magnitude and direction of the magnetic force on this particle? So if I have y, z, and x-axis, it says the particle lies in xy plane and travels at an angle of 55 with respect to x-axis. So it's going to be something like that, 55. And there is a uniform magnetic field of 1.3 Tesla parallel to the y-axis. So that's going to be the direction of B. And it says what are the magnitude and the direction of magnetic force. First of all, let's find out the direction. If we have the thumb toward velocity and four fingers toward y-axis, then palm is showing positive side of Z. But since we are dealing with the negative charge, we need to make it the other way around. So then it means that force is going toward negative side of Z-axis or negative Z direction. Now let's find out the magnitude of the magnetic force. F equals to B times V times Q times sine theta. F is the magnetic force in terms of Newton, which we will need to find it. B is the magnetic field strength, which is given 1.3 Tesla. V is velocity of the particle. It is 580 meters per second. And Q is negative 7.9 microcoulomb, which we need to convert it to coulomb. We don't really need to put the sign in here because we are dealing with a magnitude now. And then we have sine theta. Theta is the angle between V and B, which in this case is going to be 90 minus 55, which will be 35. So it's going to be sine 35. So 1.3 times 580 times 7.9 times 10 to the power of negative 6 times sine 35. That is going to give me 3.42 times 10 to the power of negative 3 Newton. So that's going to be the magnitude of magnetic force on this particle.